Hello there, you slightly under specification ape. We need to talk about your brain. Specifically, the fact that it is smaller than the brain of a person who lived 30,000 years ago and had never seen a wheel. Not slightly smaller, measurably, repeatably, embarrassingly smaller. The average modern human brain sits at around 1,270 cubic centimeters. The average early Homo sapiens brain was closer to 1,500. That is a roughly 15% reduction. We are going to find out why. This is the Ape Files, and today we are opening a case on the slow, quiet, extremely inconvenient shrinking of the human brain. First, let's establish what we actually know and how we know it. Paleoanthropologists measure brain size using endocranial volume, the amount of space inside the skull. You fill the skull with sand or water or mustard seed. Researchers have used all three, apparently, and you measure what comes out. Modern CT scanning lets us do this digitally now, which is both more accurate and considerably less messy. We have done this to hundreds of skulls across thousands of years of human history. And the pattern is clear. Brains got bigger for a very long time, peaked, and then started getting smaller. To understand the shrinkage, we first need to understand the expansion, because the story of why brains grew is equally strange. 3 million years ago, our ancestor Australopithecus had a brain of about 450 cubic centimeters, roughly the size of a chimpanzee's. That brain was enough to crack nuts, use simple tools, and navigate a savanna, and it worked fine for millions of years. Then something changed. Around 2 million years ago, with the emergence of Homo habilis and then Homo erectus, brains started expanding fast. Homo erectus reached about 900 cubic centimeters, double the chimp. Still not us, but clearly heading somewhere. So, why did it grow? The honest answer is several things happening at once, and researchers still argue about which mattered most. The leading contender, cooking. Richard Wrangham's cooking hypothesis, first laid out in his 2009 book Catching Fire, argues that cooking food externally predigests it. You extract more calories from the same food. Your gut can shrink, and the energy you save from running a smaller gut can be redirected to an expensive brain. Brains are metabolically expensive. Yours burns roughly 20% of your total body energy, while being about 2% of your body weight. Running a bigger brain requires a dedicated energy pipeline. Cooking created that pipeline. But cooking alone cannot explain everything. Social complexity was almost certainly co-evolving at the same time. Robin Dunbar's social brain. Hypothesis. The primary driver of primate brain expansion is the cognitive load of tracking complex social relationships, keeping track of who owes whom a favor, who is allied with whom, who is cheating. That is neurologically demanding work. In other words, we grew bigger brains partly just to handle other people. And then there is the ecological pressure argument. A changing, unpredictable environment selects for flexible, generalist problem solvers. The Pleistocene climate was lurching and unstable. Big brains are essentially expensive insurance against an unpredictable world. All of these pressures are compounding. Cooking feeds the brain. Social groups need the brain. The environment rewards the brain. And so, brains got bigger. For about 2 million years, the trend was relentlessly upward, until we hit the peak. The biggest human brains on record belong to the Neanderthals and to anatomically modern humans of the Upper Paleolithic, roughly 30 to 100,000 years ago. Neanderthal average, approximately 1,600 cubic centimeters. Some individuals exceeded 1,700. That is not a rounding error. Neanderthals had larger brains than us by any standard metric. And early modern humans, Cro-Magnon, roughly 40,000 years ago, were also bigger brained than us. Taller, more robustly built, and neurologically more voluminous. These were not primitive cave dwellers in the pop culture sense. They were making art, burying their dead, navigating continents. So, when exactly did the shrinkage begin? This is where the data gets very specific and a little uncomfortable. A landmark 2021 study by De Silva and colleagues, published in Frontiers in Ecology and Evolution, analyzed brain size data across the full Homo lineage. Their finding, the most significant shrinkage in modern human brain size occurred within the last 3,000 years. 3,000 years. That is not ancient prehistory, that is Bronze Age. That is when humans had already invented writing, cities, and organized warfare. That timing is a puzzle, because 3,000 years ago, we were arguably at the height of our cultural complexity. So, what is the proposed explanation? Several, actually, and they are not mutually exclusive. Hypothesis 1, the domestication hypothesis. This is the one that should make you feel a specific kind of unease. When we domesticate other animals, dogs from wolves, cattle from aurochs, pigs from boars, their brains get smaller. Dog brains are roughly 20 to 30% smaller than wolf brains. This is not controversial. It is documented across virtually every domesticated species. The standard explanation for this: domesticated animals outsource cognitive load to the domesticating species. You no longer need to find food, avoid predators, or navigate territory alone. The environment does it for you. Now, the uncomfortable part. De Silva's study found that the pattern of brain reduction in modern Homo sapiens closely mirrors the patterns seen in domesticated mammals. We may have domesticated ourselves. This is called self-domestication, and it is a serious, peer-reviewed hypothesis in paleoanthropology, not a provocation. The argument is that the same selective pressures that tame other animals, reduced aggression, increased tolerance, cooperative social living, were acting on human populations as we built larger, denser settlements. In a dense agricultural community, hyper-aggressive individuals get expelled or executed. Patient, cooperative, socially readable individuals survive and reproduce. You are, evolutionarily speaking, descended from the calm ones. There is anatomical evidence for this. The self-domestication hypothesis predicts reduced levels of reactive aggression, reduced brow ridges, reduced overall robustness, increased docility. Sound familiar? Modern humans are visibly less robust than our Pleistocene ancestors. Smaller faces, thinner brow ridges, lighter bones. We have the skeletal signature of a domesticated animal. We just built the farm ourselves. Now, let's move to hypothesis 2, the dietary shift. The Neolithic transition, the switch from hunting and gathering to agriculture, dramatically changed what humans ate. The agricultural diet, at least in its early form, was nutritionally inferior. More calories, yes, but less protein diversity, fewer micronutrients. We know this from the skeletons. Early agricultural populations show signs of anemia, stunted growth, and increased tooth decay compared to their hunter-gatherer predecessors. A brain is built from fat, protein, and specific long-chain fatty acids, the kinds that were abundant in wild game and fish and scarcer in a wheat and barley diet. If your brain needs premium fuel and you switch to regular, it may simply not maintain peak hardware across generations. This does not mean agriculture was a mistake. The caloric surplus it created is what allowed population growth, civilization, and ultimately the conversation you're having with me right now. It just may have come with a neurological trade-off. Hypothesis 3, the thermoregulation argument. A big brain produces a lot of heat. Managing that heat in a warm body is a serious engineering challenge. Researchers, including Kocher and Karbowski, have proposed that as body size decreased in warmer climates and populations spread to warmer latitudes, thermal pressure may have selected for smaller, cooler brains. This is more contested than the domestication and dietary hypotheses, but the correlation between latitude, body size, and brain volume across populations is real. The answer is probably all three of these factors operating simultaneously, which is a less satisfying answer than a single cause, but is almost certainly closer to true. Now, the question everyone is actually thinking: does a smaller brain mean we are less intelligent than our ancestors? The honest answer: almost certainly not, and the relationship between brain size and intelligence is far messier than it looks. First, absolute size has almost no predictive power for intelligence across species. Sperm whales have brains 6 times the size of ours. What correlates with intelligence across species is the encephalization quotient, brain size relative to body size, adjusted for body weight. And within a species, the brain size intelligence correlation is weak and inconsistent. Einstein's brain was below average in total volume. What matters inside a brain is wiring density, connectivity, pruning efficiency, and the ratio of white matter to gray matter. Volume is a crude proxy at best. This leads us to hypothesis 4 for why the brain shrunk, and this one is actually the optimistic reading. The efficient brain hypothesis. As brains get more connected and more sophisticated, they can do more with less tissue. Miniaturization in computing is not a sign of reduced capacity. It is often the opposite. Some researchers argue that the modern human brain, though smaller, may be more efficiently wired, with denser synaptic connections per unit volume and better pruning during development. The evidence for this is not conclusive, but it is at minimum a coherent alternative to the pessimistic reading. There is a third reading, more uncomfortable than both. What if the shrinkage reflects genuine cognitive simplification in some dimensions, while intelligence was preserved in others? Specifically, the domestication hypothesis predicts that reactive, vigilant, independent cognition may have been dialed down, the very faculties a solo hunter on the Pleistocene steppe needed most, and replaced with enhanced capacities for social coordination, language, and cultural accumulation, the faculties needed in a city of 10,000 people. Different brains for different environments, not necessarily worse, just differently optimized. Which raises a question that should keep you up at night if you think about it too hard. What are we currently optimized for? Because the environment we are in now, cities of millions, digital information, global supply chains, is different again from the Neolithic village. And we have been in this new environment for essentially no time at all, evolutionarily speaking. The brain we are running on was shaped mostly by conditions that no longer exist. We are, to be precise about it, Pleistocene minds navigating a post-industrial world with 3,000-year-old cognitive hardware that has been quietly downsizing. And yet, here we are, writing symphonies, building telescopes, and making YouTube videos about our own neurological decline, which is perhaps its own kind of evidence that raw brain volume is not the whole story. The cognitive niche we occupy, cumulative culture, language, shared knowledge, means we are effectively running distributed cognition across billions of brains simultaneously. No individual Pleistocene hunter, however large their brain, knew as much as a modern 10-year-old with a library card. The brain got smaller, the extended mind got vastly larger. These two things are probably connected. Let's close the file. The human brain peaked in size roughly 30,000 years ago among late Pleistocene Homo sapiens and Neanderthals, and has been measurably shrinking for the last 3,000 years. The most likely drivers are self-domestication, dietary shifts following the Neolithic transition, and possibly thermoregulatory pressure, all operating simultaneously as evolution tends to do. Whether this represents a genuine cognitive decline, a trade-off, or an efficiency gain remains genuinely unresolved. Anyone who tells you otherwise is working with more confidence than the data supports. What we can say: you are a mildly self-domesticated, nutritionally compromised, volume-reduced descendant of a larger-brained animal who managed, somehow, to build a world complex enough that the raw hardware may no longer be the limiting factor. Case closed, file sealed. See you next time, you slightly under specification ape.